Coming up now. Yep. Perfect.
Yeah?
Yep,
You see it?
We're all set to go. You ready to go, Erik?
No, let me just get my notes up too, so I can see where I am. Okay, let me just rearrange things a bit here. I'll put okay, yep, ready to go.
Okay, thank you, Erik, and thank you everyone here for your patience as we work through some technical difficulties there. My name is Kevin Fox. I'm chairing this session. I'm delighted to introduce Erik Brynjolfsson as one of our keynote speakers. Erik is a professor at Stanford University. He's the Jerry Yang and Akiko Yamazaki Professor and Senior Fellow at the Stanford Institute for Human-Centered AI and Director of the Stanford Digital Economy Lab. Erik is an expert in all things technical, and it seemed like we needed him here actually to sort out some of the problems. Given that we've taken up a bit of time, I'll keep my introduction of Erik to that and just say he's going to be talking about an extremely interesting topic, GDP-B, and like many of you, I'm interested to hear what he has to say. Over to you, Erik.
Thank you so much, Kevin. And what I've really been working on, especially since I got to Stanford, is thinking about how the digital technologies are changing the economy, especially artificial intelligence. One of the things we're seeing is that more and more goods and services are digital, and they have a lot of special properties. Most notably, they can often be produced at nearly zero marginal cost, and people are spending more and more time consuming them. And so as we have this revolution in the economy and a complete transformation, especially as AI is beginning to do more work and production, we also will need a fundamental revolution. And better. Just to illustrate a little bit about the one metric of this transformation, the average American today spends about 8.5 hours a day looking at screens, like many of you are looking at a screen right now. But that also includes, phone screens. People check them hundreds of times a day on average. It includes computer screens. It includes television screens. And recently, I've started using virtual reality screens. So one thing I do most mornings is I have a workout with my Meta Quest headset. I put it on my head, and I'm in virtual reality for about 15 or 20 minutes, and I do my exercise workout. It's a lot of fun. There's rock music, and it's all synchronized to my movements. So I think more and more people will also be spending time in virtual reality. 8.5 hours a day, people are awake maybe 16. So already, more than half of our waking time is being spent in a digital world. I mean, we're voting with our time, our most precious, scarce resource. We're voting with our time to consume more digital goods. In particular, bits, when they have close to zero marginal cost, it means that they often have zero price or very low price. So much of the stuff I consume, Wikipedia, search, YouTube, I don't have to pay for that. Sometimes I have to watch an ad or two, but oftentimes I don't even have to do that. And when things have zero price, with few exceptions, they aren't well captured in our official statistics. Our GDP statistics don't do a good job of tracking things with zero price. And if over half of our time is spent consuming things with zero price or very low price, we have a growing problem. And I say growing because, of course, some decades ago, the time spent on that was very little or close to zero for many people. And it's only likely to grow over time. So if we want to have a measurement apparatus that understands where people are spending the majority of their consumption, we need to be able to better measure the value of zero-price goods. So GDP-B is a new measure of economic welfare that seeks to address that opportunity. And in brief, what it does is instead of measuring the money that we spend on something, which, as I said, sometimes is zero, it estimates the value, the consumer value that you get from it. You're mostly economists in the room there, so I think you understand the idea of consumer surplus. And we can't measure it quite as precisely as we can measure spending, but we can get a rough estimate of the consumer surplus that you get from different goods and services. And you can see that can be very valuable for these digital goods. It can also be valuable for other goods and services. And what I'm going to show you is, and let me move forward here to the next slide here. I'll give you a little agenda. First, I'm going to explain a little more detail how GDP is not necessarily a measure of well-being and how GDP-B does a better job. By the way, the B in GDP-B stands for benefits. It measures the benefits, not the cost. We'll apply that to 13 different countries so you can see how it varies across different countries. And there's some initially counterintuitive results that you get when you look at these different countries. And I'll tell you more about that in a minute. But then you can also apply it to a broader basket of goods. And David Nguyen, I think, yesterday explained a little bit of what we're doing there, where we take this approach and measure not just the consumer surplus of digital goods, but also conventional goods, beef and pork, air conditioning, cars, all the other things that we buy, haircuts. And you can get a sense of how much consumer surplus we get from them and then compare it to the digital goods. The fourth thing we'll talk about is some really exciting opportunities to use AI agents. Large language models can simulate humans, and they can do it surprisingly well. So we've been exploring how an LLM agent can simulate what a human would do. You could tell an LLM that you are a farmer in Iowa, or you are a software developer in San Francisco. You are 20 years old. You are 30 years old. Here's your income. You instantiate them with some demographic characteristics, and then you ask them questions about what their buying habits and preferences would be. It turns out that the LLM can, if you don't push it too hard, if you don't go too far outside the range of what they've seen before, they give answers that are often surprisingly similar to what a real human would give. So we've calibrated it. Since we have, from part 3 there, we have 30,000 interviews with real people about their preferences. We can compare those to the LLM agents, and we'll show you that you can often use them to get similar answers. And this is amazing potential for extending economic research and survey research. Another fun thing you can do is you can ask them to place themselves in some year in the past, or perhaps even some year in the future, and the LLMs will make estimates of what they would value the goods in that different setting. And so that creates kind of a time machine. The fifth thing I'll talk about is some of the externalities, limitations, and extensions, of all this work. These are things that are not well captured in existing GDP statistics, and GDP-B, as we've currently done it, doesn't do a great job of capturing them either. But as we extend it, I think we'll be able to do a better job of understanding these externalities and even just call them internalities when people are not always rational themselves in their purchases. And finally, I'll wrap up with a bit of a call to action. I'll describe our research agenda going forward. It's extremely ambitious, and we can't do it ourselves. And so I'm going to encourage all of you to participate if you'd like. And we want to help by providing some of the tools and infrastructure to make it easy to scale this up to other countries, to other goods and services, to new categories of goods and services that we haven't done yet. And if we do this, I think we're going to have an economic measurement apparatus for the 21st century that's very exciting, that's every bit as consequential as what Simon Kuznets and others developed in the 1930s when they developed the main economic infrastructure that we're using today. Let me say a little bit about the folks that are involved in it. The core research team, in addition to me, some of you have heard from David and Sophia. Also, Avi Collis has been a real pioneer doing this stuff. This started with his dissertation work, and he's actually presenting a version of it right now at Wharton. So we're out covering the field with all four of us doing presentations these 2 days. You just heard from Kevin. He's been an amazing helper, especially doing his work with Erwin. The two of them pioneered the theoretical basis for much of what we call GDP-B, and that's written up in an article in the AEJ macro that is just coming out right now. We couldn't ask for better collaborators on that. Felix is an expert on some of the empirical methods. A lot of them are being brought over from the marketing field, where they've been doing related stuff with conjoint analysis for decades. So we can build on top of a whole body of research there that he's an expert in. And then we're very lucky to have an absolutely outstanding advisory committee of some of the leaders in the field. And we met just last March in person to go over this and periodically check in with them to think about how we can improve the methods and go forward. So let me go into the first topic, this GDP versus welfare concept. Maybe the most important question in economics is, how are we doing? What is our economy like? And the way that people typically answer it is when you say, hey, the economy grew, what do they say? What do they really mean when they say the economy grew? Almost inevitably, they're using that as a synonym for GDP. And so they'll say GDP surged by 8.4%, exceeding expectations. That's what it means for the economy to grow. Likewise, when we measure how we're doing, we look at productivity, and we compare it over time. And as you know, that's another great metric of how we're doing. People have just come out and directly said that this is the measure of our standard of living. The Boston Fed, where I used to be on the advisory committee, says that that is GDP is our measure of our standard of living. Or Forbes says that productivity is. I think there's some truth to both of those things. That said, if you really are careful about it, it's not precisely correct. Simon Kuznets himself, who really was the father of the whole GDP apparatus, has this famous quote that most of you have probably said and used in your own talks: the welfare of a nation can scarcely be inferred from the measurement of national income as defined by GDP. And that's because GDP is a measure of production, not well-being. It's what we're producing, and some of those things that we produce create a lot of value, some create very little value, some actually create negative value. So, the more pollution we have, or the more prisons we have, the more guns and poison we have, those do not necessarily improve our well-being. So it is an important measure of production, and it's fair to say that most production contributes to our well-being, but there's not a one-to-one mapping, and it's kind of a rough guide rather than a precise economic mapping. And productivity doesn't solve that problem because as most of you know, productivity is just defined as GDP divided by hours worked. So if GDP has these problems, and then productivity isn't going to solve them, just dividing it by hours worked. In particular, if something is not captured in GDP, it won't be captured in productivity either. And let me illustrate this. First, I'll do it with some graphical diagrams, and then we'll get into some algebra to discuss it a little bit more. But I think the graphics really tell most of the story. So let me think of about three types of goods. The first one I'll call classic goods, and this is what most of the economy has been for most of the 20th century. You think of, automobiles, haircuts, apples, bananas, cars, shirts, whatever things that you just buy. For most of these things, if you were to say double the production, so you move from the light pink rectangle the light blue rectangle at the bottom to the dark blue rectangle at the bottom, you've doubled production. And to a first approximation, you're also doubling consumer surplus. So in these cases, GDP, which is proxied by this spending that you're doing on these different goods, how many items are you producing, is not a terrible proxy for growth in consumer surplus. A percentage change in one is pretty strongly correlated with a percentage change in consumer surplus as well. So that's great. And that's why a lot of our intuition comes from. And it works pretty well for all those kinds of goods. For digital goods, we have a problem. Digital goods, as I mentioned earlier, often have zero marginal cost or close to zero marginal cost and zero price. So, I can consume twice as much YouTube. There can be twice as many articles on Wikipedia. I use the map twice as many hours. Any of those things would give me a significant increase in consumer surplus, but it wouldn't increase my dollar spending on that, and there would be no real measure. Maybe there'd be a small change in the amount of electricity or something, but as you can imagine, it's really has almost no correlation with the amount of consumer surplus that you're getting there. And as a result, this is something where we're missing most of the value, and that's really was the inspiration for our project to more directly measure consumer surplus rather than using this spending as a proxy. So that's pretty bad, but it gets worse. So a third case is what I call transition goods. These are goods that started as conventional goods, that started being made out of atoms, and then they get converted to being made out of bits. And more of the economy is going this way. Like if you think of an Encyclopedia Britannica, which is now defunct, but many of you had that in your home when you were a kid. It was a set of physical volumes, very expensive, and a lot of knowledge in it. That's been largely replaced by Wikipedia, which has even more knowledge. It has orders of magnitude more articles and more detail, and people have done comparisons in terms of the accuracy, and it's kind of in the same ballpark, actually. Both of them have some level of errors, but Wikipedia is certainly more current and more detailed, and even for older topics, it's in the ballpark of similarly accurate. You also see it in things like photography. I'll talk about that in a little while. So here, initially, you're spending rectangle B there on Encyclopedia Britannica and getting consumer surplus in the area A there. But if you go to zero price, if you get Wikipedia instead of Britannica, then you get this whole additional consumer surplus, the darker green area. So consumer surplus has gone up tremendously. GDP has gone down. So now they're going in opposite directions. And if anything, this isn't close to being to scale, because it's likely that the consumer surplus is orders of magnitude larger than just the quadrilateral that we have down there near the bottom. So parallelogram, I guess. No, that's not a parallelogram. Quadrilateral, we'll call it. There we see an additional problem there with the growth of it. Now, what's happening in the economy is this just a theoretical problem? No, I think it's a very important empirical problem. Hal Varian, the great economist at Berkeley and at Google, highlights that there's a lack of appreciation for what's happening with all these digital goods because we don't have a good way of measuring it. And you've used most of these goods here. They're all available for zero price, and they create a lot of value. And in fact, we're getting some amazing new goods now. These AI goods like ChatGPT or Gemini just had a new version come out yesterday. Claude is a remarkable AI program, and you can buy versions of them that cost you something per month, but there's also some amazing just free ones that most people use that give you tremendous value. And this has transformed our economy, and it's in the process of transforming it even more as AI starts infusing almost every task in the economy. But what's happened to our official measures? If you look at the information sector, it's pretty flat. You're going back to 1997, or I have another a chart that goes back to the 80s, and there's been very little change in the share of the economy going to the information sector that includes this explosion of free digital goods. So even if we're spending, as I said, up to half our waking hours on this, it's not showing up in our official statistics, and that's a concern. It's also in other areas like smartphones, what's happening in smartphones and cameras. And so here we see that if you look at the number of photos taken worldwide, and Hal Varian documented this, in the year 2000, it was about 80 billion. A few years ago, it was 20 times more, 1.6 trillion photos. So we just, we take so many more photos now than we used to. I take them almost every time I go out to dinner with friends. And at the same time, the price per photo has gone down from 50 cents to essentially 0 cents on the margin. So by any reasonable metric, that would be a huge change in our welfare and our consumer surplus. But it doesn't show up in our GDP measures because the price index for photography is based on, historically was based on film, developing cameras, all of which are vanishing. And photos, in contrast, are not priced. When I take photos and share them, I don't generally sell them to my friends. I just share them. And I think that's the way most people are. Maybe sometimes we post them on a photo sharing website. That non-monetary transaction doesn't show up in GDP. And it gets worse because the cameras themselves are also disappearing. There were 121 million of them sold in 2010 and just 8 million, barely any being sold anymore. So that's been another place where we have the sign going the opposite direction. And smartphones aren't just absorbing cameras. You may have seen this chart of all of these items that were available in 1993 in an ad at Radio Shack. And almost all of the things that were for sale in this ad are now part of a smartphone available for free. The camera, alarm clock, the music player, calculator, phone, of course, movie player, recording device. And actually, there are new things that are so much better, like the GPS map and the web browser, book reader, that didn't even exist back then. So now let me talk about the new approach a little bit, which is called GDP-B. The B stands for measuring benefits. It's especially good for two kinds of goods: free goods, as I mentioned, also new goods like the smartphone that I just talked about. But in principle, it can be applied to any type of good. And so that's what we're going to be doing as well. Just to calibrate where we are, the way I think of it is on the far right and the bottom right, we have our existing macroeconomic indicators like GDP and productivity. I would say that they are among the most objective measures we have. They're also among the most precise measures we have. But as I just argued, they're not always as relevant to well-being. They sometimes have the wrong sign. There are people who try to, at the top left, measure well-being. I don't know. Can you guys see my cursor if I point it here? Is that pointer visible to all of you?
Yes, it is. Yeah.
Yes. Okay. So these well-being metrics, there are folks that measure, say, happiness on a scale of 1 to 10, and they just survey people, sometimes thousands of people in different countries, and they get some kind of an estimate of that, and they find that people in maybe Denmark are happier than people in Bangladesh on average, but it's a pretty coarse measure. It's a 1 to 10 scale, and it's somewhat correlated with things that you might expect, like health and longevity and material well-being. But then GDP I see as being somewhere in the middle, and in fact a little bit, not just a direct convex combination of the two, but having some of the strengths of the macroeconomic indicators. I wouldn't say it's quite as objective and precise as GDP, but it can be pretty close, as you'll see. And I also think it's much closer to really measuring, what people's value is. It puts a dollar value on it. So it gives this new point in the space. So our approach then is to use the cost and expenditure functions to rework the theory, allowing there to be free goods with an imputable price. And this is where Kevin, who you just heard from a moment ago, and Erwin have been really helpful in developing this theory in some of their own papers, as well as in this paper I mentioned about GDP-B. And we use the reservation prices and the total income method to get at that. And then we can derive an explicit term for the value of both free goods, but also new goods contribution to welfare and GDP growth. Here's the paper that goes into the detail about exactly how we do that. So I'll refer you to that. On the empirical, and we'll talk a little bit more about the theory in a couple of minutes, but on the empirical side, we've been using this technique called massive online choice experiments. While the digital economy poses a lot of challenges, it also creates a lot of opportunities for us to use some new tools that just were not feasible before. And one of them is the ability to go online and do a lot of these choice experiments. Tens of thousands, hundreds of thousands. Now we're actually literally doing millions of these experiments online. And we can do that at scale at an affordable price because of the digital infrastructure. And what we do is we run these discrete choice experiments where we ask people how much we have to pay them in order for them to be willing to give up a particular good. Like, how much would I have to pay you to stop using Facebook for a month? Some people would do it for $1. Other people wouldn't do it even for $100. And there's lots of other people at values in between. But we can, do that. We can do it in an incentive-compatible way that we only pay them if they agree to give it up, and we monitor that they have actually given it up. We can recruit a representative sample so that we know that this is fairly reliable, and use that thereby to estimate the consumer valuation. I'll show you in a minute how you do that, but you get this downward sloping demand curve for that. And then once you've done that, you can see how much Facebook contributes to GDP growth by seeing how much consumer surplus there was each, or at least contributes to consumer welfare, I should say. There was no Facebook in 2004, and then over time it got to be a bigger and bigger share. So you can see how that grows as a share of the consumer surplus that people are getting. And you can do the same thing for lots of other goods, Instagram, Snapchat, Maps, LinkedIn, etc. And we've done that both online, as I mentioned, but also in a laboratory in the Netherlands. And we'll show you some other projects where we've done it on other kinds of platforms, like using Facebook itself. So here's one of the ways that we can get a lot of data very quickly. Google has something called Google Consumer Surveys. And sometimes instead of paying for an article, you can be asked to do a short survey. And this allows us to get access to millions of representative consumers. They can make sure that they're demographically balanced. And we give them, at the bottom here, you can see an example of a little survey that we ran and asked people whether they'd be willing to give up Facebook, in this case, for $5 or keep access. This one's not incentive compatible, but in other ones, we do it in an incentive compatible way. So to give you the first set of findings, and we'll go in more detail, these do generate plausible demand curves. It doesn't matter exactly how you do it. You can do it with single binary discrete choice experiments like the one I just showed you. You can use something called BDM lotteries. You can use best worst scaling. We've tried a bunch of different methods. You get very consistent answers. When you force people to be incentive compatible, that is, you require them to actually give it up, often the values are higher than the ones when we just do it a hypothetical, like what would you be willing to pay? So that suggests that in many of these cases where we're not doing it incentive compatible, just the hypothetical values are probably lower bound estimates of the true value, and we're probably underestimating the true value compared to what it would be if we could do incentive compatible for everyone. The reason we don't do incentive compatible for all the experiments is just that it's very expensive to actually pay people and to enforce it, and it requires a lot more infrastructure. So we only do it for a subset of the goods rather than trying to do it at scale. But this gives us some kind of a sense of how close the hypothetical answers are to the incentive compatible answers. Here's a sense of where the median values are. Search consistently comes out as the most valuable. Google search, emails, also very valuable. Maps have a huge amount of value, all the way down to messaging and music, still very valuable, but not as valuable as those other categories. And the Facebook consumer surplus averages out to about $38 a month for the median consumer. Again, they pay zero, but they're getting, according to us, you have to pay them $38 in order to get them to stop using it. So that suggests they're getting a significant amount of value. Since then, there have been a number of other people who have also done these experiments, like Matt Jenskow and a couple of teams at University of Chicago and elsewhere, and they get very similar kinds of numbers. So there seems to be some consistency in these results. And as I touched on, we're going to discuss in more detail, this can be scaled up to lots of other goods and services. So let me first show it to you for Facebook, and then I'll show you a few others. So here's the demand curve for Facebook, the median willingness to pay. As I mentioned, it's about $37, $38. The confidence interval, we didn't do that many surveys, so there's a pretty broad confidence interval between $27 and $51, $52. But you can see that it's fairly estimated there. And it's consistent with what you might expect, that when you looked at the people who spend more time on Facebook, they consistently had higher valuations. The people who had more friends on Facebook also reported higher valuations. The people who posted more frequently, the people who watched more videos. Women, on average, had significantly higher valuations. Older people had higher valuations. We're not quite sure, but it may be that younger people are on other platforms, are aware of other platforms, and they don't find Facebook as useful. And the people who don't, you can test that more directly. The people who spend less time on Instagram and YouTube also tends to have higher values for Facebook. So all of that kind of passes the smell test, that it's broadly consistent with what you'd expect And I also like the fact that you get a sort of a downward sloping demand curve there, as you can see on the right. As you try higher values, more people are willing to give up Facebook, and lower values, they're more interested in keeping Facebook. Wikipedia, has a value of about $150 a year on the average, so it's pretty significant for something that's free, no ads, no price to it. And here are downward sloping demand curves for the others. These are all on a log scale, by the way. You can see it better here. If you look at the y-axis, these are the dollar prices we offered them. And for Wikipedia, there's some people you had to pay, thousands of dollars in order to get them to give it up. They really get a ton of value. Some people as little as $1, but there's a whole range of people there. So you see these downward sloping demand curves on a log scale for email, search, maps, video, e-commerce, social media, messaging, music, etc. So you can categorize lots and lots of different kinds of goods and services, and you get fairly consistent results. Let me say a bit more about the theory, and I'm just going to do a time check here. Okay, so actually, you know what? I'm going to skip through this theory a bit, but the gist of it basically is, I'll just say it qualitatively, what you want to do is estimate how much you have to compensate somebody in order for them to be willing to give something up. So free goods are not traditionally counted as part of GDP, as we mentioned earlier. But if you were to count the utility that people get from them, one way to do it is to basically say, suppose, and this, I can see my cursor here, suppose you have the access to the free good, and compare that to how much you have to pay them if you don't have access in order to have the same utility. The difference in the amount you have to pay them is a measure of the willingness to pay for that. And then you can take that and look at the total income that you would need to have in cash in order to get the same level of utility. And comparing that over time, you get a sense of how much GDP-B has grown over time. So applying that methodology, as we do in the paper, and you can read it in that paper I mentioned earlier, it turns out that Facebook added about 0.68, 2/3 of a percentage point to GDP growth over this entire period. If you spread it evenly, which is a little arbitrary, but if you spread it evenly, it's about 0.05%, so like 1/20th of a percentage point. And so Facebook by itself would have raised GDP growth, a little bit from 1.83 to 1.87. That's just one good. Obviously, all the other digital goods together would be much larger, but this shows how one good could, has contributed to our welfare growth, our GDP-B growth, and I can quantify that fairly precisely. In a recent paper, we generalized that to lots of different goods and services, and we did it for lots of different countries. We did, to be more precise, we did it for 10 different digital goods, and we did it for 13 countries. We were able to do this for so many goods in so many countries because we partnered with Meta, the owner of Facebook, and that allowed us to do about 40,000 of these surveys. We also were able to do strong incentive compatibility that we could actually shut off, or ask them, test whether they had shut off access to Facebook when we paid them. We also had detailed information about their demographics, so we could control for that. And we were able to do, as I mentioned, an international scope, about 13 different countries. So we got people to opt into this survey, and the countries were the United States, United Kingdom, France, Germany, Spain, Belgium, Romania, Norway, Ireland, and Canada, as well as Korea, Japan, Mexico, and others. To ensure compliance with actual usage, we actually did this, and we asked them if they were willing to stop using it. In this case, this is $40. I showed you one earlier, it was $5. We tried lots of different values. And we could monitor whether they had actually do this, and that avoid this hypothetical bias. On average, when we actually enforced it, we had to pay them more than when we didn't enforce it. So the hypothetical answers people gave tended to be lower. People said, oh yeah, I'd be willing to give it up for $5. But if you really held them to it, then they wouldn't give it up. They would only give it up for for $10 or $20. And so we tried a bunch of different valuations, randomly assigned between $5 and $100, or the equivalent in other countries, because not everybody uses dollars. And 1 in 50 actually got selected for the incentive compatibility. And so we paid out about $20,000 to those. You know, it was pretty high compliance rate. In addition to doing it for Facebook with this single binary discrete choice method, which I just showed you, we can also use something called best worst scaling, where we compare relative valuations. In this case, instead of saying, you know, take it or leave it, this good for dollars, what we can do is give them a whole list of options and have them rank what is the most valuable and what is the least valuable. So for instance, we could say, you know, which would you rather have, access to Facebook or access to Google, or you could have multiple different goods at a time. So for instance, in this one, there's YouTube, WhatsApp, and Snapchat, and you have to say which one you're most willing to give up for a month and which one you're least willing to give up for a month. So we looked at all of these goods here, Google, Facebook, Twitter. You can read the whole list here. We also had included one non-digital item, meeting friends in person. Would you be willing to give up meeting friends in person for 1 month, just to kind of calibrate where it stood compared to all of these digital goods? And you guys can wonder right now where that ranked compared to giving up access to these other different goods for yourself and what you think it might be for other people. And since we got the valuation from Facebook, the dollar value from Facebook, and that's in here, we could see how these other ones ranked compared to that dollar value. So we basically first did the Facebook valuation, get a dollar value, and then we did these relative valuations, so you could see which ones were more than Facebook and which ones were less than Facebook. And you could use methods from marketing to see how far they were from that dollar value to estimate their own dollar value. So here's what it looked like. About 19% have a valuation less than $5 for Facebook. About 27% had a valuation over 100, and there's lots of people, all these intermediate levels there, a nice downward sloping demand curve. The overall median valuation across the 13 countries are about $31. So, you know, not that different than what we got for the United States there. Minimum was $11 in Romania, maximum was $57 in Norway. And here's the valuations for all of the different countries. So in Norway, as I mentioned, is the highest, goes all the way down to Romania, the lowest, and where's the UK? There is Great Britain. So that was about $35 in there, dollar equivalent. There's two charts there. The blue one is just the direct answers we got. The orange one is if you weighted by demographics. You know, it's not that different. And this is the overall average, about $31, as I mentioned. So you can see that people have different values in different countries. And we also did this for all these other things, and you could see now you get to see that meeting friends was pretty high up there, but not quite as high as Google search. YouTube, Google Maps, all the way down. Twitter had the lowest valuation. But you know, there's some people who have very high values for any one of these. Once we've done this, you can also get a sense of the overall valuation of, if you take the sum of these digital goods. Here's the total value in the United States. Google search was the highest, then friends, all the way down to Snapchat was the lowest in that case. In Germany, Google search was still the highest, although in this case, WhatsApp was a close contender. YouTube, not nearly as high. But Korea was a little different. There, YouTube was actually the highest, even higher than Google search. People were not as interested in WhatsApp, Instagram. So they, you know, in Korea, I guess they like to watch those videos. And then in Mexico, the one that came out the highest was WhatsApp, not as high as Google search or Friends. So, you know, somewhat different pattern. Kind of, if you look at it, it looks like a broadly similar trend of downward sloping, consistent with what the United States had, but different countries have slightly different valuations. WhatsApp, as you can see in particular, is super valuable in some countries, and other places it's not used nearly as much. So if you add up the total value for these, it adds up to about $2.5 trillion worth of welfare. That's a pretty significant number just from 10 goods. Most of that value, or almost half of that value, is in the United States. That has the highest sum. Germany, Britain, Mexico also have very high values. The value contribution in Romania, Ireland and Norway is not as high. Obviously they're just much smaller countries, so part of it's just a function of that. If you look at it as a share of GDP, this is really interesting. Mexico actually had the highest share. It was equal to over 20% of GDP just from these 10 digital goods. So that's a remarkable pattern. In Japan, these 10 digital goods were worth a little over 5%. And if you look at this, you'll notice that, interestingly, the highest values tend to be in countries with lower GDP per capita. And there is a bit of a upward slope that the richer countries do spend more, but the slope is only 0.68%. So it doesn't grow as fast as GDP. In other words, it tends to benefit poorer countries somewhat more than richer countries in percentage terms, although in absolute terms, it benefits the richer countries more. And that's what that key takeaway is there. We also were able to look within countries. Facebook has this cool tool called the Relative Wealth Index. And basically, the Relative Wealth Index, RWI, estimates how wealthy a group of people is based on other characteristics, like how expensive the homes are in their zip code and their spending and so forth. And for this study, we broke it into 3 terciles: the richest third, the middle third, and the poorest third. And that's what these different colors are. The orange one is the highest wealth, and the green one, the blue one is the lowest wealth, and the green one's in between. If you look at it, they all sort of, actually, interesting, tend to have this bit of a U-shaped pattern, but there's no clear correlation that the lowest value group is often the medium tercile. The poorer tercile often has a higher value than the other ones. So there's not a sense that richer people spend more. Obviously, they have more money available, but they don't have more value for these goods. So this also suggests that it is the welfare from digital goods is disproportionately benefiting lower income countries as well as lower income individuals. And that's because, while a rich person, as somebody tweeted here, can pay for a faster car or a private jet, everybody has the same phone, has the same access to Facebook. So rich and poor alike get access to these free goods, and so it benefits poor people proportionally more. Let's talk a little bit about the surplus for digital versus conventional goods. And this is a team that I'm doing with David and Sophia, you heard from, and Avi is also involved. So we're assessing the values for both digital and traditional goods, and we have about 30,000 respondents that we're doing this, trying to be on a demographically representative group. We just finished the first wave of it, and I have some very preliminary results, but the goal is to have a representative basket of goods in the U.S. economy, not just digital goods, but also non-digital goods. So traditional goods like milk, coffee, steak, frying pan, sneakers, all sorts of different things, life insurance, TVs, as well as the digital goods that we mentioned earlier. Also some public goods we can now measure, like electricity, healthcare, national defense. And we're trying to get some questions on quality of life, like how important it is to have clean air. These are somewhat speculative, but we'll see how it goes. And then we also try to calibrate that to dollars by saying, hey, how would this compare to having, say, $1,000 less over the next month or $100 less for the next month? And that allows us to see how these goods and services compare to different dollar values. And we do these massive online choice experiments, sometimes offering a cash offer. Sometimes we have open box where we just kind of get a sense of what the numbers are. And we use that mainly to initially calibrate where we should be aiming the cash offers. And most of the data comes from these cash offers. The data was collected in December last year, and just a month or two ago, we were able to get people to answer about 15 questions in 2 minutes and 30 seconds. So it was pretty quick. We want to be careful that they weren't just making up numbers. So we also put in some attention checks. Be warned here, if you're doing our survey, we will find you if you give answers to saying that you value things that don't even exist and that are just fake, or that you're using things that don't exist. So we had a few fake apps and other implicit attention checks in there. And 97% of our respondents passed them, but there were 2 or 3% that tried to cheat. So as I said, we'll build this representative basket, and we're using the consumer expenditure survey to identify. We picked 264 items from our first wave, like I mentioned some of them before: eggs, apples, cookies. Our data is fairly representative of the U.S. economy. The orange bars is the official data, and our sample, as you can see, matches it up pretty well. You know, a little bit off on a few of them, but ballpark correct. Here's the average usage rate. These are the people who we'd have to, even if you paid them $1, they'd want to keep using it. And so there are some things like Google Chrome that 80% of people, ChatGPT is 50% of people. And here are some of the downward sloping demand curves we saw. So for beef, you'd have to pay people on average about $20 for them to give it up. Air conditioning, about $34, although there are some people that you have to pay $2,000 or more. Other people would give it up for just $1, maybe they don't even have it. Google Chrome was an estimated value of 25. These are the median values, so 50th percentile. Cars, a much higher value, as you can imagine, about $1,000, although some people you have to pay as much as $10,000 or more. And here's a quick look at lots of different categories, just to give you a little bit of a feel for the ones that are more valuable. Gmail is one of the top functions. Instagram, Spotify, not so much. Electricity, as you can imagine, is something that you have to pay people $11,000 to get them to stop using that. So that would be pretty unpleasant. That's just the median value. Some people is much higher than that, and others less. Telephone services, etc. I was interested to see the personal hygiene products were so high. People do not want to have bad hygiene during the month. And if you add up the 24 digital categories, adds up to about $900 per month. That's about 18% of monthly income. That was just from these items that we looked at, the 24 items. I should say that while many of them are free, some of them you do pay for. So Netflix you do pay for, Spotify you do pay for. There's a paid version of ChatGPT. So while we got a surplus of about $166 from video and audio streaming, for instance, people on average paid $31. So the total surplus is about $197, 166 of that going to the consumers, and the total spending was included the $31 as well. On the other hand, something like Google Maps is free, so all of the value from that one is surplus. You could kind of start many of these things, of course, you pay for, especially let's just zoom in on food. And it's an interesting exercise is to get a sense of how big the consumer surplus is compared to what people are spending. So if you look at beef here, the green is the total consumer surplus that we estimated, about $16. And the spending was about $10. So that ratio is about 1.6. If you look at subcategories like steaks, on average, they spent about $3 on that category, and only got about $1.2 of additional surplus from that, so the ratio was somewhat lower. You could do this for all these different categories. In brief, to summarize them, what we found was that for the more aggregate version of it, like the whole category, like beef, instead of the subcategories, you tended to have a higher ratio of consumer surplus. And the more disaggregated ones, there was less consumer surplus. I think that's consistent with the idea that there's a little more competition there. You have more substitutability, but in the more aggregate level, it's not so substitutable. So, the consumer surplus is somewhat higher. And if you go to the entire category, the ratio gets quite high, about 4.6. If you had to give up all of these, so you couldn't substitute, fish or poultry for meat, you couldn't even have eggs, that would be something that would be very costly for most people to give up. Let me skip ahead because I'm looking at the clock here, and I want to make sure there's time for questions. A really exciting area that I think is going to be very important in the coming years is scaling up this work using LLM agents, large language models that can be agents. And Sophia talked a little bit about that earlier today or yesterday. And so I'll briefly describe some of what we're doing there. as we all know, the costs are escalating for doing these surveys and the response rates are going down. I mean, one of the ironies is that many of the human respondents are actually using LLMs to fill in the answers. So you think you're getting data from a human, but it may just be that somebody is having an LLM fill in all of their answers for them, especially on some of these paid panels. And so that may not be what you're looking for. But if they're going to be using LLMs, we want to control that ourselves and understand how accurate those LLMs are. There's been some very recent research by people like John Hurton, Park and Al, and others that are finding that these LLMs can produce responses that are very consistent with human behavior. During the Q&A, I'd be happy to talk about some of the related research by, for instance, our colleagues June Park and Michael Bernstein at Stanford that did some fascinating work showing how these agents could replicate lots of different survey responses. And we're doing that as well in our work. And that means that potentially these can extend our data samples. So calibrating them to human input would give us much richer high-frequency data, also allow us to scale up work and get more estimates. And the real question is how accurate these are, because you can't count on them for sure without calibrating them first. So we have this paper that just came out about augmenting human survey responses with Gen AI, applying to accurate research, and Sophia, I think, talked a bit about that already. But what we did was a whole bunch of different conditions here. So there are 8 different conditions, in some cases asking the LLM to pretend that it's an expert and give us the answers based on what an expert would say. In other cases, asking in the red, asking an LLM to be a particular individual, and we mapped it to lots of different particular demographics. You are a black male in Boston, you are a professor in Stanford, or whatever, and had them answer as if they were that person. So that's what the red ones are. And then we did different things. Sometimes we had to do some reasoning or metacognition. Sometimes we gave it, in addition to the demographics, we also gave it some benchmark valuations from other surveys, not the same question we're asking about, but related questions. And sometimes we did all of it. And as you can imagine, as you give it more information, it often tends to do a little bit better at answering the questions. And now, somebody, Chris Galati, was saying, why aren't people using this to calculate GDP-B on Twitter or X? And so that's what we're beginning to do, is scaling up our answers with these agents. We have this large data set of 32,000 respondents that I showed you earlier, and we can use that to test and calibrate to see make sure that our LLM agents are giving reasonable answers, and then use that to interpolate for different groups and to extrapolate in different ways. And as long as we don't push it too hard, I think you can get some reliable answers. Another kind of fun thing we can do that Avi Collis is doing right now, he's at Wharton in Philadelphia, presenting, as I'm speaking, a related paper, what we call it LLM time machines, where we ask the LLMs not only to pretend they're a different group or person, but also, suppose it was the year 2017, what would you say? What if it was the year 2020? How would you behave? And if we ask them those questions and we compare them to the humans, we get some very similar results. So we do have 8 waves of data now. We've been doing this for a while. So we have data going back to 2016 about how much users value Facebook. We've been doing it every year, about 12,000 surveys. And now we can ask the LLMs to pretend that it's 2016 or 2017, and what would they say? So what is the answer to that? So here's what it turns out to be. For 2016, we have the real answers and the LLM answers, 2017. And they're somewhat similar. They're not statistically significantly different. And so it looks like this. The real surveys is this light one here. This is the actual data that we got from our surveys. And the darker one is what the LLMs say. So it's sort of a somewhat similar pattern. There's clearly some noise, although it's within the error bounds of it. They both have this downward sloping thing. So the LLMs seem to be in the ballpark of what the humans would answer. We also were able to go ahead and extrapolate even further back, and we don't have anything to compare this to, but according to the LLMs, the peak valuation for Facebook was back around 2010. Early on, it wasn't quite as valuable. It didn't have as many features. And then since then, it's been falling a bit. And if you compare it to, say, Instagram, while Facebook has been falling, according to the LLMs think that Instagram has been becoming somewhat more valuable, or at least leveling off. and is now more valuable for the typical user. So this idea of LLM time machines is kind of fun because it lets you look at things that you haven't gotten around to gathering data. When we do have the data, like we do for these, it's in the ballpark. So we think there may be some credibility to it. Avi over in Philadelphia is even presenting some data about going into the future as well, even more speculative, but kind of a fun thing to play around with. Finally, let me talk, or two last things. Let me talk about the externalities and limitations, and then I'll talk about the research agenda, and then we'll have questions and answers. And I think Kevin said we could go a little longer since we started late. Is that right, Kevin?
Yep. Half past the hour is the real hard deadline.
Half past. Okay. Yeah. I'll definitely end within the next 10 minutes or so. So we'll have some time for Q&A. So there are faster than that, actually. I'll try and end because I'd like to get lots of Q&A. So taxonomy of externalities. So one of the things is, as we present this paper, a lot of people bring up is that when someone says that they value Facebook, sure, they're willing to pay a lot for it, but a lot of people kind of regret that they spend all this time on social media, or maybe it's bad for their society or bad for democracy. It has other kinds of costs. And the simple way we're doing the consumer surplus experiments right now, the massive online choice experiments, doesn't really capture those negatives. To be fair, our existing GDP doesn't capture it either. People pay for cigarettes even though they cause cancer. People buy internal combustion engine cars even though they cause pollution. So, GDP doesn't really do a good job of capturing the negatives either for the individual or for society. But we'd like to try to address this a little bit, both the individual cost and societal cost, also both the short term versus the long term, because I think often someone's valuation, say for Facebook in the moment, could be a lot higher than their value if they're kind of using System 2 from Kahneman and Tversky and thinking, is spending an hour a day on social media something I really want to be doing? So we have this categorization. Sophia has taken the lead in doing this. So the first is, as I mentioned, there's these direct costs and these indirect costs. So the direct costs include, reduced productivity from excessive screen time, addiction and mental health. There is some evidence from Matt Jenskow and Hunt Alcott and others that people who use social media may have some mental health challenges, especially teen girls. There's the potential for privacy loss, inability to process lots of information. It could hurt your relationships. It can cause eye strain, distracted driving. You can have all sorts of potential negatives. Some of them may be very important, others may be small, but I think it's worth just having a taxonomy of all of these. We also have costs to other people. So it can cause misinformation, and it could be a tool for spreading misleading content. There's some evidence that false information spreads faster on Twitter than accurate information. It's more likely to be retweeted or reposted, perhaps because false information tends to be more exciting and more provocative than the truth, and that's something that people like to repost. There's evidence that it can lead to political polarization, affect social cohesion. There can be market concentration effects. Some people pointed out that there are, cost of running these data centers and environmental costs from that. So all of those could be some externalities that you might want to consider. And then finally, as I mentioned, you could also think about both the short term that happen immediately versus the long term that extend over a period of months or years, and some effects that happen in both those categories. So I just, step one is just to identify these categories, and then we want to start putting dollar values on it. Our existing GDP-B of looking at the benefits finds these dollar values, $30, $40, $50 a month, that people are willing to pay. But there may be some negatives on the column on the right there. Attention and time. Maybe there's lost productivity, privacy loss, misinformation. And we haven't done this yet, so these are speculative numbers, but we could estimate some of these values. As I mentioned, Alcott and Jenskow and Song, their digital addiction paper did find that up to 31% of social media use is due to lack of self-control, and people actually prefer not to do it. So maybe you should knock 30% right off of these numbers here. at least for Facebook, and who knows, maybe for lots of other goods. Maybe some people regret buying that, red sports car, or buying the cigarette, or having all those potato chips. Our agenda is ultimately to have a much richer taxonomy of all of this. There are this top category: traditional goods and services, goods with positive price. GDP does a pretty good job of measuring those. So that's this box. But then I talked about zero price. That's the second category. Household production and government a lot of that's not well captured in GDP, non-market services. So that gives us another category. And then there's some things like leisure and personal activity that may be very valuable that are not part of GDP. And then ultimately, you could even go into health, education, environment. So all of these different things, in principle, we'd like to understand better as contributors to welfare. Our methodology with GDP-B, we could in principle go out and ask about them. Maybe you're more confident, I'd be more confident in some of the answers for these higher ones, and the answers for the lower ones would be a little bit more speculative. But as I sometimes say, it can be better to be approximately correct, even if you don't get the number very, very precise, than to be very precise but wrong and be missing most of the value. And so our goal is to ultimately get a broader set of items into the GDP-B framework. So let me wrap up with a call for arms, and then we'll have some questions from all of you. Our research agenda is to regularly publish these GDP numbers. We're in the process of getting our very first wave put together that David presented, and I presented a little bit of it. I'd love to do it annually, and then if we get the funding, we could do it on a quarterly basis, matching official GDP numbers. We'd like to expand the number of items. Right now, we have a few hundred that is supposed to be representative, but I think I'd rather have like a few thousand to make it even more representative, and especially get at some of these substitutability issues that I hinted at earlier. It would be nice to start adding quality of life factors. We already are pretty far down doing some work with household production. Zhupeng Wang has contributed a great deal of work to that, and we should soon have some numbers on that. But you could go for these other categories as well. We're going to need help to do that well. Different geographies, so adding different countries or subgroups would be useful. And we're hopeful that we can do this at lower cost by using these LLM agents. If we start having credible LLM agents, we could scale this up dramatically without having to survey millions of humans. And of course, that would be faster and lower cost. Here's a schematic of what our agenda is. We've done a pretty good job of doing the digital goods, and we've done that for lots of different countries. I showed you across 13 different countries here, and we'd be happy to have share our surveys with others if they want to bring it to other countries. We're beginning to do it for other goods and services. So I showed you, food categories, et cetera. We are pretty far along with the household production. I imagine within a month or two, we'll have some data. Well, maybe a few months, we'll have that ready. And we'd love to have teams helping us with health, environmental, and culture, and do that ultimately for all these different countries. And then once we've done that, we want to do it again. So do that for 2025, then do it for 26, 27. And the real value, I think, is when you start getting a time series, so you can see which categories are growing and which ones are shrinking. So let me just wrap up by saying that GDP-B was traditional GDP was one of the great inventions of the 20th century. It's the de facto metric of our economic growth. But if you really want to understand, especially goods with zero price, but really all goods, you want to understand the benefits, you need GDP-B. We have some tools that allow us to do this at scale with massive online choice experiments. And it can measure it for different countries. It can do it for LLM agents, and it can be extended to these new categories and geographies. So it's a very rich toolkit for measuring the economy. I'd love to have more people participate in it. Our team is ready to support you if you want to bring this to a new category or a new country. We can give you a lot of infrastructure so you can do it very quickly without having to reinvent the wheel. If you want to learn more about it, there are 7 papers now out that do this in various aspects of it. I talked a little bit about a couple of them, or you can go to this website, gdpb.org, that points to these papers and has a little bit more detail. So let me just stop there and save the last few minutes for questions, and I'll do my best to answer them. And I'm going to ask Kevin to answer any really hard ones. Thanks.
Thanks very much, Erik. Time for questions, comments, and complaints. Martin.
Thank you very much for a fascinating lecture. I can relate what you say to the the literature on the introduction of new goods and services into both output deflators or output indices and consumption deflators or consumption indices. But when does one of these new goods stop being new? I mean, for example, I'm a Facebook holdout. If I were to start using Facebook, to give me the average or the median value for my consumer surplus would be quite misleading. The consumer surplus I would have thought would be close to zero. Thank you.
It absolutely would be zero. It would be absolutely be zero for you. And there's lots of people who get zero consumer surplus. The numbers I showed you were for the median person, but we have a whole demand curve, and there's millions, tens of millions, hundreds of millions of people who have zero surplus from Facebook, and they will for some time, and they will until and unless they start using it. There's others that have a much higher value. Once a good is in the national accounts, we don't have such a problem because then we can measure the change in price, and we can, if there is one, and we can measure the change in adoption. The real problem is that that when it doesn't exist at all, and then it starts existing, how much should we think of that? And one way to think about that is that there's a virtual price, an imaginary virtual price that is so high that it sets the consumption to be equal to zero. So before Facebook existed, you could imagine that there was that it did exist, but the price was $10 million. And then when people started using it, that meant that the price had come down to something more manageable, and that difference is a way to calibrate how much additional welfare was got from those first few sets of users. It'd be a very small set of users, but they might have gotten a lot of value. But your key point is exactly spot on, that there's many people who get precisely zero value from lots of goods and services.
Thank you. The gentleman just along from Martin.
Hi, I went to the talk earlier about using LLM agents to extend survey responses. And one thing that wasn't really mentioned in that talk was about the ability to compare, if you did this, between countries. So I'm imagining, like, if you're using GPT-4o, that's going to have a training data set which is overrepresentative on, like, kind of the Western world and America, probably. So
yeah.
Have you seen that, like, when you've done these studies, extending the survey responses, if you say, can you pretend to be a French person instead of an American person, like, is it as good at predicting the outputs, the same as the 0.6?
Well, a French person may be unrealistic, but a British person, no. But to be fair, yes, you can calibrate it for lots of different subgroups, and it does some better. There are several different techniques. You can use a different context window and RAG, where it goes and looks things up. You can do some fine tuning and additional data. I mentioned some work by June Park, Michael Bernstein, and Percy Lang and others. Absolutely fascinating work where what they did was they interviewed about 1,000 people for 2 hours each and used that data to train a set of LLM agents. And then afterwards, they found that the LLM agents were extremely good at mimicking those people. They looked at the general social survey and had the LLM agents answer, and they answered it almost as well as the same person answering that survey would. And you could ask them a set of questions and then ask the human those questions two weeks later, and the LLM agent, by the way, humans, when they answer the same questions, don't always give the same answers. So there's like about an 85% correlation. So the LLM agent, has some noise, but it's not that far off from a person answering the question themselves. This is all to say that there's a very active research agenda, and Sophia is a big part of that, and so is Jose Ramon in my lab, and David and others. We are trying to understand when those LLM agents are reliable and when they're not reliable. And your intuition is exactly right, that the more different it is from the base training model, the less reliable they are. You can fix that a little bit with some fine tuning and with some, a context window where you put more data into it. But if you start getting very far from the kind of training data that was used, it starts becoming less reliable. So I wouldn't ask it, about, a rice bowl in Vietnam, without some extensive additional fine-tuning or retraining of the model. And that can be done, but it does limit the applicability of it.
Question down here.
Thanks, very interesting talk. Just a question about your assumptions on independence of the observations in the discrete choice model and the stated preference type that you've done. When you're talking about like goods like meat, if I don't like meat and my friend wants, I mean these are independent choices. But things such as social market, like if someone is well influenced by friends, by community, by other people around you, so this independence assumption of the observations is more questionable for the like Facebook. If I stop stop using Facebook because my community stopped doing that, then they find a more like a cooler application to be adopted, or the government policies in certain countries ban it or something like that. That's how that affect what you're doing.
Yeah, thank you. That is a great question. So let me break it into two parts. First off, we are able to compare it. One of the most exciting things about this is how different values of different and consumption of different things. I showed you briefly, for instance, that people who use Instagram tend to have lower values for Facebook, and people who use, who don't use Instagram have higher values. So certainly, if you start using a substitute good or a partial substitute, that will affect your valuations. Likewise, if you like, beef and chicken equally, then it's not as big a deal if you stop eating beef. Then you can switch over. But if you really have a strong preference for one or the other, or a vegetarian or something like that, then that's going to change how the taking away one good affects others. And that's definitely something we want to include in there. It's something we start measuring explicitly. We think it's an exciting tool, say, for instance, for antitrust. When you look at these different digital goods, what the implied substitutability is across the different ones. The second part of your question had to do with, I think you can think of it as sort of network effects or community effects. For instance, I showed you that WhatsApp values were very high in some countries and very low in other countries. That really doesn't have to do with the fact that the features are very different. The fact that you translate the WhatsApp menu into Dutch doesn't make it more valuable to people in the Netherlands. The reason that it was more valuable to people in the Netherlands is a lot of other people were using WhatsApp, so it becomes a focal point for sharing information. When I first saw those numbers, like for the Netherlands, they were like 3 times higher or 4 times higher, I think, than they were in the United States. I thought there was some kind of an error, but we went and interviewed some of the people, and it turns out that in those countries, exactly as you're saying, they really depend on it because they're friends. If you want to go out on Friday night, you needed to be on WhatsApp. Even if your boss was communicating with you, they would often do it with WhatsApp. Or you want to touch base with your babysitter, it would be through WhatsApp. That wasn't the case in the United States. So whether other people are using it is an important part of the value. At first, I thought that was a problem, and I've decided, maybe generously, that I think of it as actually a feature, not a bug. It's actually good that we can measure that, and we can see that some goods are more valuable, and that the network effect is part of the value of those goods. Avi Collis, one of our co-authors, has been doing a series of experiments where he has people defriend people on Facebook and see how much that changes the value. He pays people to how much you have to pay them to stop communicating with 5 or 50 of their regular Facebook friends, and so you get a sense of how much of the value comes from this network effect versus from the direct use of it. But the GDP-B approach is actually, I think, a powerful tool for separating out where people get value. Is it the network effect? Is it the menu? Is it that other people are using it? And you can sometimes separate those different components out. A good research agenda going forward is to understand better how important they are. It's also an issue for for conventional goods. Fax machines are not valuable unless other people use fax machines. But now we have a tool that helps separate out how much is due to network effects versus other effects.
We have some online players here. So there's a question from Ryan O'Rourke about J-curves. Do you think the costs you outlined be the reason, or are the reason, new technologies have not enhanced productivity? So there's less thinking time therefore fewer new inventions, etc.?
Well, I wouldn't necessarily go quite that far, but I would do the first part of the J curve, which is, there are these intangible investments. I think Carol Corrado is there in the audience as well, and she's pioneered a lot of the work on these important intangible investments, which include learning how to use the tool, the organizational changes they're needing, different sorts of human capital investments, process changes, and all of those intangibles are costly. We don't do a very good job of measuring them in GDP, in our official GDP statistics, and as a result, the investments in creating them appear to create no value, even though I think as an economist, I would say they are creating value. They're creating human capital or organizational capital. But since they aren't measured in GDP, that creates this J-curve effect where you're investing a lot of cost, you're not getting measurable output. So initially it appears that productivity is going down. Over time, we start harvesting the benefits of that human capital and organizational capital, and that leads to a higher measured output. Now it's turning into new goods and services that we do measure, and that leads to the upward part of the J-curve. So I think that's true for many of the goods and services that we're describing here, and it is part of the reason why our official statistics are not showing much productivity growth, despite some on the surface pretty amazing capabilities, especially in some of the AI tools. As more people learn how to use them effectively, we'll be getting to the second part of that J-curve, and it makes me optimistic about measured productivity growth over the next 3 to 5 years.
Let's squeeze in one last question. The gentleman in the yellow shirt in the middle here.
Thank you. My name is Fidelis from London Metropolitan University. You spoke about using LLM for future research instead of engaging thousands of people. So my comment would be that I answer questions with regards to my personal experiences. So my response today would be different from what I'm going to answer to your questions tomorrow, likewise yesterday. So does LLM have the capacity for independence or capability to independently answer your questions without the human influence?
Yeah, so first let me just clarify. We wouldn't want to use the LLM agents instead of humans. We'd want to use them in addition to humans. I think you always want to create a reasonable human sample so you can calibrate and sort of as a reality check on the LLM agents. But the LLM agents would allow you to explore different demographic groups and different categories that you may not have as big a sample for. They allow you to interpolate on some other related goods and services that you don't have a chance to ask about. I don't think the LLM agents are going to give you as precise day-to-day variations as the real humans would. They will give you some broad averages. And what we found from our research, and Sophia presented some of this earlier, but you can look at our paper, is that you get some pretty high correlations with the broad averages as long as you don't go too far from the data that you already have. So if you have data on Facebook, it will give you a reasonable estimate for Snapchat or for Instagram, but it won't necessarily be that accurate to tell you what your value is for, say, ChatGPT, because it's a little bit more different. So the more similar your data is, the more valuable. And in terms of changes over time, we did, with the LLM time machine work, we do find some evidence that you can get the broad changes from year to year. Again, I wouldn't be able to get quite as precise as your personal change from moment to moment, but for statistical purposes, I think we can get something pretty close to the median, at least within the error range that we saw earlier. So I'm actually very excited that I suspect, I'll make a prediction here, that when you do the ESCoE conference in, say, 2 years, there's going to be a lot of papers using these LLM agents to gather economic statistics on different things. And there will be papers showing where they work well, and there'll be showing papers where they have their weaknesses, and it'll be a thriving research area of how we can broaden our toolkit to get a lot more data, especially as humans are less and less willing to participate in the surveys. But I think, let me just wrap up by saying that's just one part of this exciting research agenda. And let me reiterate the call to arms that I made at the end. We have a great toolkit. David and Sophia are there. Please hunt them down and talk to them. And if you are interested in your country or in your statistical agency using some of our tools, we'd love to make them available to you. If you're interested in broadening this to a new category like health or environment or household production, we would love to talk to you and help provide the tools. But I think over the next couple of years, we'll be using GDP-B for more and more goods and services, and we'll start understanding not just what we're spending on goods and services, but also the consumer surplus and the value that we're getting, especially from free and new goods. Thanks very much for giving me a chance to share this research with you all.
Thanks, Erik. Now there are some questions that didn't get answered. Feel free to email Erik. I'm sure he will reply, or his AI bot will reply. You probably won't notice the difference. Thanks very much, Erik, and we'll interview you shortly on another link. So thank you. Thank you, everyone, for being here and for your questions.